Okay, this one. And I need to change the IPR calculation, okay, from test data to theoretical one, which is the layer parameters. Okay, I need to input, so I just go directly here. So this is in this window, we will construct a theoretical model that should mimic the real performance which we have in test data. So I need to input all information, but make sure that the productivity index must be the same, 14, around 14.3. So that by having a model in theoretical model, okay, I can now input the data for the new layer, okay, and then later I can combine them to know the performance for Commingle production. Okay, so I just show you directly. So let's deal with the initial reservoir first. Pressure, of course, the same, temperature the same, mid-perf the same. Okay, and now I need to input permeability based on pressure build-up or based on log information. Okay, in this case, I know based on my initial assumption from direct log analysis, the permeability is 195 millidarcies with reservoir thickness of 59 feet and relative injectivity, no, wellbore radius 0.35. Water cut, of course, the same, gas oil ratio the same. Vogel equation 0.2. And of course, we will model also the calculated skin. Okay. And go to drainage area geometry. In this case, I just assume, okay, the equivalent drainage radius 250 meters. Okay. You see, my productivity index is still 0, still cannot be calculated. So I need to provide data for skin factor. Completion type, change it to case hole. I will not model the damaged skin. I don't know anything about this. I have no measurement. I have no laboratory data for this one. I have no detailed modeling to model the damaged skin, so we can skip this one. And now we focus on limited entry skin. So for this reservoir, the nearest measured formation distance is 0 feet. Okay, so the top perforation is located at the top reservoir. So the closest distance is 0 because the top reservoir, the distance between top reservoir and top perforation, 0. Okay, vertical permeability, I assume it to be 10% of the horizontal permeability, so it will be 19.5. Open interval, it's 10 feet. So you get the limited entry quite high, 21.8. Well deviation 0. Okay, so it's vertical well. So the deviation skin also 0. And perf diameter 0.37 inches. And shot penetration, we have 3.3 foot, shot density of 6, shot facing of 60. So by using log equation, I get perforation skin minus 0.1172, but actually if you just perform, usual perforation setting, perforation configuration, like this typical penetration, typical shot density, typical shot facing, perforation skin will be around this value. So you see, if I use my data, okay, from the source that I have, the productivity index should be just around 3.44. Okay, it's far from the actual productivity index I get from well test, which is 14.3. So yeah, of course, dealing with subsurface issue, we deal with uncertainty, okay? And in this case, we have uncertainty, of course, in permeability. So that's why you need to correlate the permeability from well log with permeability from pressure build up, for example, and permeability derived from the well performance, like in this equation, like in this case, I mean. So in this case, I assume that the uncertainty belongs to the permeability. So let's adjust the permeability.